Hello everyone. So in this slide, in this little video, we're going to practice the skills that we learned previously on drawing Lewis dot structures for molecules, neutral molecules, and for ions. So to do these examples, I would really recommend that you have your periodic table in front of you, because you will use that periodic table to determine number of valence electrons. And I recommend that you have maybe a copy of the rules for drawing Lewis dot structures that were from the previous video. That, and then also remembering that when we do our Lewis dot structures, that each single bond is equal to 2 electrons, and that a guiding principle for doing Lewis dot structures is that atoms want to have an octet. That means 8 electrons, valence electrons around them, except for hydrogen and helium, which want a duet of electrons, and a duet means 2. So let's jump in. Let's go ahead and start doing the Lewis dot structure first for methane, for CH4. Now I gave you the Lewis dot structure for that molecule previously in a slide, but let's talk about how we would use the rules that we talked about in the previous video to actually write this Lewis dot structure. So the first thing we would do is determine the number of valence electrons for that molecule. For the elements that we'll be dealing with for Lewis dot structures, the group number is equal to the number of valence electrons that that element contributes. So since carbon is in group 4, it contributes 4 valence electrons. Hydrogen is in group 1, so it contributes 1, but there are 4 of them in that molecule, so I multiply that by 4. And so completing that sum, I have 8 valence electrons that I need to place in my Lewis dot structure. I start my Lewis dot structure by writing down my first atom as the central atom. Your first atom is always going to be the central atom unless it's hydrogen. If it's hydrogen, hydrogens are always at the ends of bonds, not in the middle. So I write down my central atom, which is carbon. I'm going to scatter my 4 hydrogens around the carbon. Doesn't matter where you put those hydrogens as long as they are scattered around the carbon. Now I'm going to start to place my 8 valence electrons, and you do that in the order that we talked about previously, which is first making single bonds between your central atom and your outer atoms. Remembering again that each single bond is equal to 2 electrons. So when I draw my Lewis dot structures, I like to count by 2s just to kind of keep track of the valence electrons that I've used. So in making single bonds from my central atom to my outer atoms, 2, 4, 6, 8. I have made my single bonds from my central atom to my outer atoms. I've used 2, 4, 6, 8 of my 8 valence electrons. So I have to stop. There's no more electrons I can place. And that's good because carbon is happy with an octet of atoms, or with an octet of electrons, excuse me. Remember, electrons that are in bonds shared in between 2 atoms contribute to the octets or duets of both. So this central carbon atom has 2, 4, 6, 8 valence electrons. Each hydrogen has 2. So this is the Lewis dot structure for CH4. Let's go ahead and do the same process, the same steps with NH3. Determine number of valence electrons from the group number of each atom, taking into account the number of that atom that's present. Write down my central atom, which in this case is nitrogen. I'm going to scatter my 3 hydrogens around. And just for now, I'm going to put that 3rd one there. Now so I've scattered my hydrogens. I'm going to start to draw my single bonds from my central atom to my outer atom. And again, I'm going to count by 2 just so I can keep track. So 2, 4, 6. I have used 6 of my 8 valence electrons. I've got 2 more valence electrons I need to place. The next step would be to place those remaining electrons on the outer atoms to complete their octets. In this case, for NH3, my outer atoms are all hydrogen. And hydrogen, they don't want an octet, they want a duet. Each hydrogen in NH3 already has a duet of electrons. They each already have 2. So, if you have the octets or the duets of your outer atoms completed, and you still have valence electrons that need to be placed, any extra electrons then get placed on the central atoms. So in this case, my 7th and my 8th valence electron will be placed as a lone pair on my central atom, which is nitrogen. So I have now placed 2, 4, 6, 8 of my 8 valence electrons. My hydrogens are happy, each with a duet, and my nitrogen is now happy with an octet. The nitrogen has 2, 4, 6, 7, 8 valence electrons. So this would be the Lewis dot structure for NH3. Now let's go over to the right-hand side and do Lewis dot structures for these ions. So in this first one, for Cn, this is our first instance where we have to deal with this negative charge. And as we said in the previous video, when doing Lewis dot structures for ions, we need to take into account that charge by either adding or subtracting the appropriate number of electrons. Since this Cn ion has a -1 charge, it has 1 more electron, we have to add 1 because of that -1 charge. So in Cn negative, 4 valence electrons from carbon, 5 from nitrogen, 1 extra from that negative charge, so I have a total of 10 valence electrons. So I know in this molecule I've only got 2 atoms, so it's kind of hard to think of an atom as being central. But in this case I think it's instructive. Use this carbon as like the central atom since it's the first atom, and then consider the nitrogen as being an outer atom. That's going to be helpful when we start to make our single bonds and octets. So I've written down my carbon, I've written down my nitrogen. I'm going to consider this carbon as like a central atom. I'm going to do my single bonds, remembering that single bond is 2 electrons. So I've got a single bond between the carbon and the nitrogen. So I've used 2 of my 10 valence electrons. I'm going to complete the octet on my outer atom, specifically nitrogen. Right now nitrogen just has 2 valence electrons. It needs 8. So I've used 2 here. So 3, 4, 5, 6, 7, 8. So nitrogen now has 8 valence electrons, and I've used 8 valence electrons to make this Lewis dot structure so far. But I need to use 10, so I have 2 more I need to place. So any extra electrons you have after completing the octets on the outer atoms go on the central atom. So that 9th and that 10th electron will go on the carbon atom. So I have now placed all 10 of my 10 valence electrons. Now we need to look to see if my octets have been satisfied for my for all of my atoms, or if I have any hydrogens, if the duets have been satisfied. Well, this nitrogen here on the right, it has an octet of atoms, of electrons, 2, 4, 6, 8. But this carbon only has 2, 4 electrons. So once you see that an atom needs an octet of electrons, you can't add any more electrons. This is where you look to see if the atom attached has any lone pairs of electrons that it would be willing to donate or share with that other atom. In this case, nitrogen has 1, 2, 3 lone pairs of electrons. So nitrogen could very easily donate 2 lone pairs of electrons that can shuffle in between the carbon and nitrogen. And doing that, my single bond now becomes a triple bond because two of those lone pairs are now in between the carbon and the nitrogen. I still have this lone pair up here on carbon, but now all of my atoms are happy, meaning all of my atoms have an octet of electrons. The carbon has 2, 4, 6, 8. Remember, each single bond's 2 electrons, so if I have a triple bond, 2 times 3, that's 6. Nitrogen also has 8 electrons. The only other thing we need to add with this Lewis dot structure for Cn negative, we need to somehow note in our Lewis dot structure that it is negative by putting a bracket around it and the charge as a superscript. These brackets and this charge as a superscript has to be done for ions, either anions or cations. So we're going to be doing that with Nh4 as well. But this would be our Lewis dot structure for Cn negative. Last but not least, let's do Nh4 ammonium ion. Go ahead and do our valence electrons. 5 from the nitrogen, 1 times 4 for hydrogen, but I have a +1 charge. That means I have lost an electron. So since I have a +1, I have to subtract 1 from my total valence electrons. So in this molecule, I have 8 valence electrons. I'm going to have nitrogen as my central atom, scatter my outer hydrogen atoms around the central atom. So I have my center atom of the nitrogen, scatter my outer atoms, start to make single bonds between my center atom and outer atom, counting by 2. 2, 4, 6, 8. I have used 8 of my 8 valence electrons. I have to stop because that's how many I've got to use. My hydrogens are happy with a duet. My nitrogen is happy. My center nitrogen is happy with an octet because it has 2, 4, 6, 8 valence electrons. The only other thing I need to add for this Lewis dot structure are brackets and a superscript plus. So those are some good representative examples of Lewis dot structures for neutral molecules and for ions.